New topic, taxes. Okay, we're going to talk about a couple of things with taxes. The first one is what taxes do to markets. And spoiler alert, they create dead weight loss. Do you all remember dead weight loss? Dead weight loss is a loss of surplus due to distortions in behavior in the market. Okay. So there are going to be a couple of important lessons about taxes. And first, in a market, there are buyers and sellers. Either side of the market could be taxed. Okay? And in a labor market, there are buyers, employers, and there are sellers, workers. Either side could be taxed, and there are payroll taxes paid by workers, payroll taxes paid by employers. Okay, one important lesson that economists have, or one important insight, is it doesn't matter which side of the market pays the tax. The impact will be the same. And taxes will reduce, by the way, taxes will reduce happiness. Okay? And they reduce happiness, surplus, for two reasons. One is you give up money to pay the tax, but the second is the distortions that happen. That's the dead weight loss. Okay. And again, first, it doesn't matter which side of the market actually pays the tax. The impact will be the same. Okay. But, slides are out of order. I apologize. Okay, reduce surplus because, tax revenue and dead weight loss, but taxes reduce surplus to both the consumers and the producers. Okay, an important thing with taxes is elasticities in the market. Okay, elasticities will impact both the revenue generated by a tax and the dead weight loss, as well as how much of the burden of the tax falls on the consumer side of the market versus the producer side of the market. Okay, so I'm going to start with a little example about taxes distorting behavior. So the general thing is, if you tax something, people respond to incentives, and they're going to behave in ways that help them avoid paying the tax. Maybe it's not consciously avoid paying the tax, but they will respond in ways where they shift away from doing whatever is taxed. Okay, and as an example, think of an income tax. Okay? An income tax is a tax paid on how much I earn, but how much I earn depends on how much I work. The higher the income tax rate, the lower my incentive to work. Okay? I may have mentioned this before, but my salary at this university is sort of approximately based on how many courses I teach. Okay? And so I kind of have a decision. How many courses do I want to teach over a year? The more my income is taxed, the lower my net income. Okay, so there's maybe two definitions of income. One is gross income. Okay, this is pre-tax. Okay, so imagine the university pays me $1,000 to teach a class. Okay, And that's what comes from the university. That's the price that the university pays. And then I pay my taxes, and after my taxes, I have my net income. Okay. My post-tax income. Okay. And the difference between the two is simply like minus my income tax. Bless you. Income tax is usually a share of or a percentage of what I earn. So it might be 25% of what I earn. So again, the university might pay me $1,000. There's a 25% tax on my income, which means that my net income, after taking out the taxes, is $750. And then I, as a worker, have to decide, is it worth my time? You know, I could be sitting at home watching TV. Is coming to work worth $750? And so I make my decision. Now, if the income tax rate goes up, my net income goes down, right? If the income tax rate is 25%, I get $750 from teaching the course. That's my net income after tax. Raise the tax rate to 40%, the income tax rate to 40%, then I have a net income of $600 from teaching the course. Raise the income tax rate to 50%, my net income from teaching the course is $500. Now, if you keep raising the income tax rate, at some point I am going to decide it's not worth the trouble of coming to work. Okay? I mean, this is the basic idea of the law of supply. As the price I receive for working goes down, the quantity of labor I supply goes down. Okay, and in the extreme, imagine a 100% tax on income. Okay, so the university pays me $1,000. I pay 100% of that in tax to the government. I end up with $0 from working. What's my incentive to work? Nothing, right? Will I work? No. To be honest, I probably still would, but don't tell my employer that. Okay. So for the thing about this, though, is it's a pretty bad outcome. This 100% tax rate results in no income to me, but also no revenue to the government. Yeah? If I'm not working, how much do they get? Nothing. Okay? And this causes, this 100% tax rate causes any surplus to disappear. That's almost a worst case outcome. So as I describe it here, it's a pure dead weight loss. It's purely inefficient. As a matter of fact, what I'm describing here has a name. It's called the Laffer curve. And it comes from an economist named Art Laffer. Okay, he thinks about the relationship between the income tax rate and how much revenue is generated from the income tax. Okay. Which tax will generate more revenue? For example, think about this. A 25% tax on income or a 100% tax on income? Right? 25% of tax on income will actually generate more revenue. You believe that? Okay. So, basically, Laffer points out, we know there are two ways to get zero tax revenue. Okay. If you tax income at 0%, you get zero revenue. there's no tax. But also if you tax income at 100%, you'll get no tax revenue from that. No one works, so there's no tax revenue. Okay, so we know those 2 points along this relationship between tax revenue and income tax. Okay, though we would expect that a low tax rate, a 5% tax rate, will generate some tax revenue. A 10% tax rate will produce revenue. It might be more, it might be less. Okay, so anyhow, if we kind of trace out how much revenue the government gets as a function of what the income tax rate is, like what percent of income is taken by the government, we'll get some relationship that looks kind of like this. Okay, okay, as the income tax rate increases, for a while, government tax revenue will increase. And there are kind of two things working in opposite directions. Raising the income tax rate means that the government gets to keep a larger share of what people earn. But offsetting that, as the income tax rate goes up, people earn less. They work less, so they earn less. That's just simply the law of supply, labor supply. Those two things work in opposite directions. There'll be a point right here where the government maximizes revenue. After that, raising the income tax rate anymore will reduce the amount of revenue that the government collects. Again, it's just a simple, logical idea. And this economist, Art Laffer, by the way, that's my depiction of Art Laffer. Okay. See, he's a laugher. He's laughing. Okay. He apparently just sketched this one evening at a dinner table. He sketched it on a paper napkin. He was like, listen, it's just common sense. This has to happen. And there has to be some tax rate that will maximize income. If you keep raising the personal income tax rate, eventually it'll be counterproductive and the government will get less revenue from higher income tax rates. And so Art Laffer was influential on really conservative politicians from the Reagan era onward. And there was even a term, or there is a term, Reaganomics, combination of Reagan and economics. But President Reagan certainly took this perspective that Art Laffer came up with and uses justification for reducing taxes on the rich. Okay? Belief was that at the time, the top income tax rates on the wealthy, which were, I think, around 40%, were too high, and that the economy would, or that the government would be able to get more tax revenue if it would cut income tax rates for the wealthy. Okay, again, that idea was known, it was a part of Reaganomics. And it's remained a part of really conservative politicians' general beliefs since then. I mean, the big question is, what is this X percent? What's that magical percent that maximizes government revenue? And if you raise the income tax rate over that, the government starts getting less revenue. Again, Art Laffer was suggesting that was like maybe a 30% income tax rate. Liberal economists were suggesting that it might be a 70% income tax rate. So there's kind of a debate over where exactly that point is. But again, something that I'll emphasize is that a 100% tax rate is completely counterproductive. It is the worst possible outcome for everyone. A 0% tax rate, at least I take a job and I work and I get all that money, which I get to spend, and that makes me happy. Doesn't do anything for the government, but it makes me happy. 100% tax rate, I don't work, I have nothing to spend, and the government gets zero revenue. That's just the worst case possible. And that is more or less the idea of deadweight loss. Raising taxes reduces total surplus. Okay, so let me do a little example of surplus in a market. So let's imagine a market where widgets can be produced at a fixed cost or a constant cost of, $50. Okay, and think about how much surplus would be generated in the market. Okay, so I have a variety of consumers. We have different values for widgets. One person would value a widget at $64. Another would value it at $62. And so if one widget were produced, that first widget would go to the person who values a widget at $64. And remember the definition of total surplus is value minus cost. Okay, or total value minus cost. Okay, first let's think about a market where there is a tax of 0. Government does not tax widgets. Okay, now a little bit of a change from the income taxes I was talking about. Income tax is usually set as a percentage of what people earn. Okay. Now I'm going to think about a per unit tax, which is how commodities are often taxed. Okay, now surplus from selling these widgets. Okay, first widget. The person who buys it, it's worth $64. The cost of producing it is $50, so it generates $14 of revenue. Second widget, brings someone $12 of value. They can pay a factory $50 to produce it. Don't have to pay any tax, so they get $12 of surplus. The third widget, and brings someone $60 of value. It costs $50 to produce. No tax gets paid. And so bottom line is it produces $10 of surplus. Next widget, $8. Fifth widget produces $6 of surplus. Sixth widget produces $4. Then $2. Then 0. Then the ninth widget would bring someone $48 of surplus, and they could find someone willing to produce it for $50. So if it were produced, it would bring negative $2 of surplus. And the 10th widget, it would bring $46 of happiness. It would cost $50 to produce, so it would generate negative $4 of surplus. Now, these last two things, those are not going to happen. Okay. If I'm a consumer and I value a widget at $46 and it would cost $50 to purchase it, I would not purchase it. Okay, so here's a simple market. A couple of things to notice. The quantity sold in this market would be 8. And the total surplus generated is 14 plus 12 plus 10 plus 8. Okay, 16. It's 48 plus 8, 54. $54 of surplus. Okay. I think I added those values together correctly. Um, um, yeah. Okay, $56 of surplus. Okay. Ooh, 56? Oh, hell. Yeah, it's 56. I apologize. Okay. Now, basically, the scenario I'm talking about, if we want to think of this in terms of supply curves and demand curves, I've got a market where the supply curve is just this fixed cost, and what was it, $50. Okay, widgets could be produced at a cost of $50, and so that determines the price at which which producers are willing and able to sell widgets. And they'll sell as many widgets as you want at $50. Okay, demand curve was downward sloping. The lower the price of widgets would be, the more people would purchase them. Area of surplus is the difference between the demand curve and the supply curve, or the price that people pay. Okay, so just adding up for each consumer the difference between the value they get from a widget and the price they pay. So it's that area. Oh. Now, I want to do a similar idea, except let's bring in a tax. The consumer has to pay $3 for each widget that they purchase. Okay, so the consumer goes through and evaluates benefit from purchasing a widget. First consumer, they value a widget at $64. They would have to pay $50 for it to be produced. They would have to pay a $3 tax. So it leaves them with $11 of surplus. And just as a note, yes, they would go ahead and do that. They get positive surplus from that. Second consumer does the same kind of calculation. $62 benefit minus $50 cost to get it produced minus $3 to the government leaves me with $9 of surplus. So yes, go ahead and do that. And so on. So I've written down these values, but once we get to the sixth widget, okay, the consumer gets $1 of surplus from that. So the consumer would purchase that, okay, but no longer the seventh or eighth widget, right? In the market with no tax, the consumer or the consumers would have purchased 8 widgets. With this $3 tax, consumers purchase 6 widgets. Now I filled out the bottom of this table the tax generated by the 7th widget and 8th widget are 0, right? The consumer is not going to purchase them. Okay, so these, like the potential 7th, 8th, 9th, 10th widgets generate no revenue for the government. Okay, so if we do the math here, add up the consumer surplus, 11 plus 9 plus 7 plus 5 plus 3 plus 1, adds to $56 of consumer surplus. The government revenue, government sells, consumers buy 6 widgets, they pay $3 tax for each widget, that adds up to $18 of revenue for the government. So in some ways, this is the surplus has been converted into, bless you, the surplus has been converted into, or let me say the original surplus has been converted into some surplus plus some tax revenue plus something else. Okay, so in the first case, like with no taxes, there's $56 of consumer surplus. With the tax, there's there's $36 of consumer surplus. And there is $18 of tax revenue. Okay, add those together, it gives you 54. So there's $2 that's kind of missing. Okay, and that's deadweight loss. And basically that comes from this seventh widget would have produced $2 of surplus for the consumers. But they're not buying the seventh widget because taxes are too high. Okay? It would have brought $2 of surplus. But if they have to pay a $3 tax on buying it, they don't buy it. So no surplus is generated from the seventh widget, and no tax revenue is generated from the seventh widget. That's essentially the deadweight loss. And I can go through some other examples where the tax keeps increasing. Raise the tax to $6 a widget. Consumers go through the same calculation. The widget would bring me $64 of happiness. It would cost $50 to produce it. I would pay a $6 tax, which leaves me with $8 of surplus. So that consumer would say, great, let's go ahead and do it. I still get surplus from it. And the second consumer does the same type of calculation, ends up with $6 of surplus, even after paying the tax. Great, go ahead and do it. Okay, and so on, down through the fifth consumer. Okay, fifth consumer would be willing to purchase that widget, but not anymore. Okay, no one would be willing to purchase the sixth widget even, right? Because, like, if you look at the sixth widget, it brings, the sixth widget brings $54 of happiness, and it would cost $50 to produce. Now, in the absence of any tax, that sixth person would want to purchase a widget because it brings them $4 of surplus. Okay? But if they have to pay a $6 tax when they buy a widget, $4 surplus minus a $6 tax results in negative $2 of surplus. I hope that's clear. Like, they would have to pay more in tax than the value they get from it after the cost, so they don't do it. Okay, so that $4 of surplus that potentially they could have gotten in a competitive market, they would have gotten, it's gone. And also, the government is getting no tax revenue from that. In this case, if we add up the total tax revenue, there are 5 widgets sold. The government gets $6 of revenue from it. Consumers get in total $20 of surplus. So when we add those up, tax revenue plus surplus is $50. Okay. What happens to the remaining $6? It's deadweight loss. Like, no one gets that surplus. Okay. And I do the same example again, tax of $9. The higher the tax is, the larger the deadweight loss is. In this case, deadweight loss is 20. Okay. By the way, I'm going through these slides quickly instead of doing all the calculations for a couple of reasons. One is, I think you all can process it quickly. Second is, I will be posting these slides on Moodle. I've been doing that throughout the semester, so if you want to go back and look at the values, they will be there after class. Okay, so let me explain what this looks like in the model. So we've got a market with some supply, and supply is just this flat line at the cost of producing a widget. So in this case, it was $50. Okay, the producers were willing and able to produce as many widgets as people wanted at a cost of $50. Okay, then there's some demand from consumers and downward sloping demand curve. The market equilibrium in a competitive market with no taxes occurred where the demand curve and the supply curves intersected. So that's where Q star occurs. Okay. Now, that was all in the previous picture that I did a few slides ago, and I showed you that consumer surplus was everything above the supply curve up to the demand curve as far out as the quantity sold. So all of this area is consumer surplus, CS, in the competitive market with no tax. Okay, but then the tax comes along, and the tax essentially shifts up the supply curve by the amount of the tax. From the consumer's perspective, the new price they pay is the cost of production, $50, plus whatever the tax is. Okay? So this P prime is the price to the consumer, okay, including the tax. Okay. Then the new market equilibrium will occur where the new supply curve, S prime, intersects the demand curve right here at this point. Okay? And the equilibrium quantity sold will be Q prime. So the tax, it raises the price that the consumer pays for the widgets, and consequently, the quantity demanded goes down. So price up, quantity demanded goes down. Now, consumer surplus is always the area below the demand curve, above the price that consumers pay, and then out to the quantity sold. Okay. So in this case, it's the blue triangle, yeah, between the demand curve and the price they pay with the tax as far out as Q prime. The tax revenue is the amount of the tax, let me say the per unit tax, times the quantity sold. Okay, and that's this purple rectangle. It's a rectangle. The width of the rectangle is the quantity sold, and the height of the rectangle is the per unit tax. Okay, so that purple rectangle represents the tax revenue. Now, if we remember, when the market was in equilibrium without a tax, everything out to Q star was consumer surplus. Okay, so all of this stuff that I'm shading in blue right now, that was all consumer surplus. Okay, but with the tax, only the upper blue area is consumer surplus. Okay, the purple rectangle is tax revenue. What about the remainder, that gray area? That's dead weight loss. Okay, that is surplus that would have existed had there been no tax, but the tax changes behavior. And people purchase fewer widgets because of the tax. And they get no surplus from those widgets that they are no longer purchasing. And that's like these widgets between Q prime and Q star, they are not being purchased because of the tax. Okay, not purchased because of the tax. Okay, so no surplus comes from them. That's the source of the dead weight loss. Okay, this is a very simple example where I kind of simplify the supply side of the market. There's nothing going on with supply, it's just like a constant cost. More generally, markets have upward sloping supply curves. So I'm going to do like a more realistic or model of the market, like the standard model of the market. This was very simplified so far. Okay, here, a market for widgets. Upward sloping supply curve, downward sloping demand curve. The market equilibrium occurs where supply and demand intersect, which is at this point right here. Okay, the competitive market price with no tax would be P star. Quantity consumed would be Q star. We can break this up into consumer surplus and producer surplus. Consumer surplus is the area below the demand curve, above the price that consumers pay, as far out as the quantity consumed, Q star. Producer surplus is everything above the supply curve up to the price that producers receive, as far out as the quantity sold. So it's that orange triangle. Now, I've got a couple of ways of modeling the market. First is, suppose there's a tax that consumers need to pay on widgets. And it's a $T tax for each widget paid. This tax will shift the demand curve down by exactly the same amount as the tax. So imagine, for example, that this point on the demand curve, the original demand curve, means that at this point right here, imagine that indicates that people would have been willing to purchase 8 widgets at a price of $10. Okay, I mean, just to make up some numbers for that. Well, if the government then adds a tax of $3 that consumers have to pay for each widget they buy, they would have purchased 8 widgets at a price of $10 when there's no tax. Now, the equivalent is they will purchase 8 widgets when the market price is $7, which means the total price the consumers pay is 10. Okay, so this point right here is $7. Yeah? If consumers would have purchased, I hope this makes sense, like whatever quantity consumers would have purchased at the old price, they will purchase that same quantity if the new price is knocked down by exactly as much as the tax. And that's why this whole demand curve shifts down by exactly the quantity of the tax. Okay? So that's the original point on this slide, is that the whole demand curve shifts down by exactly the quantity of the tax. And then there will be a new market equilibrium where demand and supply intersect. Okay? The new demand curve and supply curves intersect. Okay? So I'm labeling that point Q prime is the quantity sold, and P prime is like the official price in the market. Without the tax. Okay, so it's what the producers receive. Okay, consumers pay a different price. The price to consumers is higher by the amount of the tax. So if you go up to P prime plus T, that's the quantity that consumers pay. Okay. But one thing to note as well, the quantity in the market goes down. Right? In equilibrium, with no tax, number of widgets sold was Q star. With the tax, the quantity sold drops to Q prime. As I pointed out, there's a price that producers receive, P prime. That's like what the widgets actually cost in the market. But on top of that, consumers need to give some money to the government, T dollars, which is like the price with the tax. Okay, think of the following, if you're trying to grasp what I'm getting. You go to the grocery store and you pick up, I don't know, a packet of bread, no, a box of widgets. That box of widgets is labeled $1 as a cost. You go over to the checkout stand and you ring it up and the cashier says, that'll be $1.09. Okay, what's the difference? It's the sales tax, right? And there are kind of two different prices. When you purchase that box of widgets, $1 is going to go to the seller, the store, and 9 cents to the government, and you pay $1.09. Does that make sense? And so in this case, it's like P prime, the price received by the seller is $1. The price paid by the consumer is $1.09, and the difference is that 9-cent sales tax. Okay. So let's do the surplus. Definitions of surplus will remain the same. Consumer surplus is the area below the demand curve and above the price that consumers pay as far out as the quantity sold, Q prime. Okay? So it's that blue triangle. Producer surplus is everything below the price that producers receive down to their supply curve as far out as the quantity sold. So it's that orange triangle. Tax revenue is the rectangle in between. Okay? That has a height of the amount of the tax, and the width is the quantity sold. So you multiply those together, per unit tax times number of units sold gives total tax revenue received by the government. Okay, now the final is not labeled here. Okay, the deadweight loss. This triangle right here that I've shaded in gray, this is deadweight loss. Okay. Often in these types of analyses, the deadweight loss is often the area between the demand curve and the supply curve from Q prime to Q star. Okay, Q star is the quantity with no government policy, and Q prime is the quantity with the government policy. Okay, that's a general thing about the deadweight loss. Okay, it's the area, like in terms of quantities, between the quantity that is sold with the policy, like the tax in place, between that and what it would have been in a competitive market. So between those two quantities, and then the height is between the demand and supply curves. Okay, so I think I'm out of time for today. Thursday,